Here I want to find a limit of a function involving absolute value. I'm going to make a table to help me understand what the function looks like. I'll pick inputs of -3, -2, all the way through at least 2 here. Now, absolute value takes the negative away and makes it positive. So that's going to become 3 over -3, which will be a -1. I'll do the same for -2. And again, it's -1. There's a pattern here. For every negative value, this function produces a -1 output. But if we plug in 0 here, we get an indeterminate form. What happens if we put in a positive value? Well, now the outputs switch to a +1. And no matter what positive value you put in, it's going to be a 1. So what does this look like as a graph? It holds a value of -1 for all inputs to the left of 0, and all the way up to 0, it holds that value. Then suddenly it will switch to +1 as an output on the right side of 0. And it's undefined at 0 itself. So that's the function. Notice that since the limit on the left side of 0 limit as x approaches 0 from the negative side is a -1, whereas the limit as x approaches 0 from the positive side is +1. That's this here. Those limits do not agree. And since they don't agree, the overall limit does not exist. Let's try a couple limits at the bottom which involve asymptotes. First, we have the limit of 1 over x. And 1 over x is a function that looks like this. So an asymptote is created at x equals 0. Let's analyze the one-sided limits. The limit of 1 over x as x approaches 0 on the negative side could be said to be -infinity. It's not real, it doesn't exist, but it is heading in the negative direction. And then we can look at the limit as x approaches 0 from the positive direction. And that is headed toward a positive infinity. Now, since those two don't agree, we can definitely say that the overall limit does not exist. But there's another reason that the limit doesn't exist too, and that is this. If the limit of f as x approaches a from the left is not a real number, or the limit as x approaches a from the right is not a real number, then we have to say that the overall limit does not exist. And so let's check out this 1 over x squared here. Because the interesting thing about this one is both of the one-sided limits are headed toward infinity. So notice here that the limit as x approaches 0 from the negative side of 1 over x squared is infinity. And the limit x approaches 0 from the positive side of 1 over x squared is also infinity. But even though they match, we still can't say that the overall limit exists because there has to be a real number L that they actually approach. So I'm going to put DNE. Does not exist.